Unit 3, Part 2. In this unit, we're going over Avogadro's number and the mole. So first of all, Avogadro's number is equal to 6.02 times 10 to the 23rd. And if we write this out in long form, you can see this number here. It's a very large number. And so we write it in scientific notation 6.02 times 10 to the 23rd because it is a very large number. But it's a very useful number, because if you look at 1 mole equals Avogadro's number. And a mole is a unit. You can have a mole of anything. You could have a mole of hamburgers, pennies, whatever it is. But in chemistry, we use the mole to measure atoms and molecules. Why? Because it makes it easier to handle molecules and atoms, because they're very tiny. And even if you have just a tiny pinch of an atom or molecule, there's always going to be billions and billions of atoms or molecules there. So by using the mole, we can actually, if you will, handle large numbers of atoms and molecules, and we can use that to perform chemical reactions. If we look at the periodic table, and so for instance what I did is I drew a box here that would represent helium on the periodic table. You'll have the atomic number, which is the number of protons, the symbol of the element, the name of the element, so the name is helium, and then the atomic mass, 4.0026. That's the atomic mass of helium. Now, if we have, and remember that 1 mole equals 6.02 times 10 to the 23rd. If we have the atomic mass, so if we take 4.0026 in grams, that would be equal to 1 mole of helium. So for instance, if we have 4.0026 grams of helium, right, that's going to be 6.022 times 10 to the 23rd atoms of helium, which again is 1 mole. If we doubled it, so if we had 8.0052 grams of helium, you would have 2 moles. Which would be 75.992 grams. I would have 4 moles of fluorine. So if you look at chlorine, which has an atomic mass of 17, the symbol is Cl, right? Our name is chlorine, and if I had 35, the atomic mass is 35.45. 1 mole of chlorine would be 35.45 grams, which again is equal to Avogadro's number, 6.022 times 10 to the 23rd atoms of chlorine. If you look at bromine, it has an atomic mass of 35. Its symbol is Br, right? Our name is bromine. and the atomic mass is 79.90. If I have 1 mole of bromine, I would have 79.90 grams, which is equal to 1 mole of bromine, which is 6.022 times 10 to the 23rd atoms of bromine. And again, if I double the mass of bromine, so if I take 79.90 and I multiply that times 2, I would have 159.8 grams of bromine, right, which is equal to 2 moles of bromine. Okay? Now let's take this a little bit further. If I look at chlorine, right, again, we said the atomic number is 17, the symbol is Cl, the name is chlorine, and its atomic mass is 35.45. 1 mole of chlorine is equal to 35.45 grams, which is 6.022 times 10 23rd atoms. 2 moles is equal to 70.90 grams. And then we would double the number because we have 2 moles, multiply 2 times Avogadro's number, and we get 1.2044 times 10 to the 24th atoms. 3 moles, we take the mass, the atomic mass of chlorine, and multiply it times 3, and we get 106.35 grams, which would be 1.8066 times 10 to 24 atoms of chlorine. 4 moles is equal to 141.8 grams, and 2.4088 times 10 to 24th atoms. So chemists, when they measure out substances to take part in a chemical reaction, they'll measure the mass of it. So if I wanted to react 1 mole of chlorine with another substance, 1 mole of another substance, I would have to put 35.45 grams of chlorine and react that with something else. Let's look at chlorine. Okay? And we can take this and look, right? Chlorine, you said, is 35.45 for atomic mass. If I had, let's say we had if I had 88.625 grams of chlorine, and we know that 1 mole is 35.45 grams, how many moles would be in 88.625 grams of chlorine, right? So how many moles? Okay, so how many moles? So how do we figure that out? We would take the 88.625 grams and divide that by the 35.45 grams of chlorine. And we call that the molar mass of chlorine. So the molar mass of chlorine is the mass in grams of an element, of the atomic mass of an atom. So the atomic mass of chlorine is 35.45, so its molar mass is 35.45. So we would divide the chlorine by 35.45 5.45 grams per mole of chlorine. And when we do that, we would get 2.5 moles. Okay? All right, so let's apply this to masses. If I have 100 grams of fluorine, right, 100 grams of fluorine, how many moles of fluorine do I have? So how many moles of fluorine, right? Fluorine has an atomic mass of 18.998. If I want to know how many moles 100 grams are, what I would do is divide the 100 grams by 18.998, right, grams per mole. And when I do that, I will get 5.26 moles of fluorine. All right, so I'm gonna squeeze it in here. So I would get 5.26 moles of fluorine. So if I have 100 grams of fluorine, I would have 5.26 moles of fluorine. And if I wanted to know how many atoms of fluorine I have, I would take the 5.26 and multiply that times Avogadro's number. So if I have, but now let's say we have 100 moles of bromine. And if we look at the atomic mass of bromine, it's a lot bigger. All right, so the 79.90 is the atomic mass of bromine, which is the molar mass in grams. So if I have 100 grams of bromine, so I'm going to write 100 here, 100 grams of bromine, and I want to know how many moles that is. What I'm going to do is I'm going to divide that by the 79.90 moles. Grams per mole. Grams per mole. And if we would cancel things out, which I really should do, you would cross out the grams and be left with moles. So what I'm going to do is on my calculator, I'm going to type in 100 and divide that by 79.90. And when I do that, I get 1 point. That's supposed to be a 1. All right, let me try that again. I got 1.25 moles of bromine. So you can see if I have a mass of an element, I can determine how many moles I have by dividing by the molar mass of the element. And we saw previously, if I wanted to measure up a certain number of moles of a element, what I can do is I measure the grams of that element, and if it's equal to the molar mass of that element, I know I have a gram. So I can do multiples of the molar mass, or I can do fractions of it, and so I can actually mass up less than 1 mole, or I can measure up multiples of the mole of that element. Okay? So this is our introduction to molar mass, moles, Avogadro's number. All right? If you have questions about how this works, you can ask me on Monday night, or if you want, I can actually, if you guys are having any issues with understanding, let me know what you're having trouble with, and I can make another a video to go along with it and try to explain it. Okay? All right, take care, and thank you.